We'll be having our next session, session number 17, that is on innovative approaches to improve dairy processing, efficiencies and product quality here in Rathi Hall. The timings are 11 to 12:30 p.m. and session number 16, which is on exploring dairy diets in the global south, which is happening in Hall on Goal. So the timings are 11 to 12:30. And session number 18, which is on consumers' expectations, is happening in hall number Sahibal, hall number 2. And it will be happening from 11 a.m. to 12:30. Alright, so it is once again a very good morning, ladies and gentlemen, and a very warm welcome to each one of you. I am Tia Sudi, your host for the day, would like to extend a very warm welcome for this IDF World Dairy Summit 2022. And I hope after day 1, day 2 sessions, you all had a great sessions, informative sessions from last 2 days. Now we'll be continuing our journey with the day 3 sessions, and here we are all set for session number 17. So how are you all doing this morning? Great? Okay, so we have the next session, that is session number 17 from 11 a.m. to 12:30, which is on innovative approaches to improve dairy processing, efficiencies and product quality. So for this, I would like to invite our session chair, Dr. M.S. Chauhan, Vice Chancellor of Govind Vallabh Pant University of Agriculture and Technology from Pantnagar. With a big round of applause, everyone, please. Now, let us introduce our speakers of this session. So we have the speaker 1, Mr. Thomas Switzer. He's Sales and Design Director, Head of Marketing, Biomar. And he will be speaking on process optimization for minimizing uses of water during dairy processing operations. We have our next speaker, Ms. Katrina. Ms. Katrina of Tetra Pak Center of Expertise Liquid Food Solution. She'll be speaking on strategies to improve energy efficiencies in dairy processing. We have our next speaker, Dr. Hari, VP and Product Research from Dairy Management, Chicago, US. He'll be speaking on driving consumer innovations through novel processing technologies. We have our next speaker, Dr. Ashish Kumar Datta, Emeritus Professor, Department of Agricultural and Food Engineering, IIT Kharagpur, and he will be speaking on market milk innovations in processing and packaging. We have a last speaker, Dr. Tridib Kumar Goswami. Yeah, he's Professor, Department of Agricultural and Food Engineering from IIT Kharagpur. And he will be speaking on innovative approaches to improve dairy products, quality during processing, storage and transportation. So once again, a very warm welcome to all our speaker and session chairs. And with this, I would like to call upon our session chair on the dais. Yeah, can we have you here, sir? Dr. M.S. Chauhan. Yeah, that's completely your wish. If you want, you can take that mic.
Thank you so much, and good morning to all of you. This is the session 17, where we'll be having a deliberations in the area of innovative approaches to improve dairy processing efficiencies and product quality. So this is Dr. M.S. Chauhan chairing this session, and before going to take this session, I would like to inform our speakers here that we have provided only 90 minutes for this session, and we have 5 speakers. So it means almost 15 minutes to each of the speakers. So I therefore request each speaker to restrict his talk within 15 minutes. And we can, at the end of this session, we can take few questions from the audience. So I will not spend much time, but I will invite directly the first speaker, Thomas H. Weber. He is a Director, Latin Marketing Biomer, Sales and Design Director, Head of Marketing Biomer, and he is graduate chemical engineer, having over 30 years industrial water treatment the experience, and he will be speaking on process optimization for minimizing usage of water during dairy processing operations. So, Dr. Thomas, please.
Thank you, Mr. Chairman. It's a pleasure, and I'm honored to be here at the World Dairy Summit. My name is Thomas Weiser. I work for a company, Envirochemie, and we are a short introduction via slides. I want to show what we are doing. Did you have had a glass of water this morning? And was it clean? It was clean. Nice. Because that is the main aim of us, to clean water. If I look around here in India, sometimes I have the feeling there are rivers full of coffee, I mean black coffee, and probably we can change a little bit into the, with our contribution to more clear water and utilization of water. When you see here the slide, in the center there is a factory, it is the dairy factory, and in the dairy there are a lot of streams of water, incoming, outcoming, cycling around CIP, and in the end we have an effluent which is slightly or has a certain pollution, and this pollution can harm the environment in case that we reject it just into a river or so, because this pollution takes away the oxygen in these rivers. So it would be recommended to clean the effluent. And in this topic, I want to go in specific into reutilization of water. Yeah, you know about the importance of water use or water reuse. And the main question is, what are the needs? What are the possibilities? And what are the challenges and the barriers? I want to visualize this with some examples by doing treatment of cow water and show you another solution like the end of pipe solution. What is population growth? It is parallel to water consumption. The more people are consuming water, the more water is consumed, and the more effluent happens. We have the climate change, and we know it's getting drier, hotter, and on the other side, it's getting rainfalls like hell, I would say. And we have the trend to urbanization and limited resources on hotspots, where there, for example, big cities are consuming a huge amount of water and there is no water available. And now going into dairy industry, when we see a dairy factory takes around 1 to 7 cubic meter of water by produced ton of product. Or if we go detail, when we process cheese, we have to consume for washing and all these needs to make a good cheese, we had to consume 4 cubics per ton of product. Or at the milk, also there is cleaning things. We have to consume water, fresh water, to keep the machines clean. And so also in the drying processes, we have a certain amount of wastewater per ton of product. The aim is to reduce the water consumption in order to give an answer to the water scarcity, and that means to reduce the water footprint of a factory or of a product. And you know also, consumers, they want to eat today pineapple yogurt, tomorrow another mango yogurt. So we have changes, and all between the changes we have to clean the machines and all that consumes water and produce wastewater. And sometimes we are in a lack of water with the necessary quality and quantity, especially in water scarce regions. So there are several approaches to go for. The production related water saving measures are, let me say, getting a certain saving, and with a small amount of, let me say, planning or engineering or knowledge. When we want to water reuse from partial streams in a dairy, then we have to think about what to do. It's more difficult to realize that, but there are certain savings of water and saving of wastewater. And when we go to the end of pipe solution, I mean the classical ETP, what to do with this wastewater in order to reuse it, that is a challenge for the engineers, for the dairy managers, and for the technicals, and for the staff. But there are huge savings possible. So there are some, I would say, barriers. I think you also think a little bit, oh, shall I eat a product produced with recycled water? Something like that. But technically, it is not an argument. It is I would say, a psychological argument. And some cost concerns. A lot of people think if we do this recycling and it makes costs a lot of money and something like that. It isn't. When you take a real balance, or when you say know the value of water, then the cost for water reuse is less. And for sure, authorities have to permit such water reutilization units. Here is an example how to win water out of a drying process. When we do milk powder, for example, a lot of milk is pure water. And this pure water, after drying, when it's getting in the condensate is, it's nearly drinking water. Only a few steps, treatment steps, are needed to take it back into the process and to reuse. It is incredibly easy, but it has a huge water-saving potential. That we realized at ALA. How many minutes? One more?
Another 15 minutes?
Okay.
15 minutes.
Two. Yeah. We realized that at ALA, there they have the condensate of this drying process has only a low carbon or organic load. So it was us to reduce this load and to take out the nitrogens and the phosphorus, and in the end it was quality of drinking water. So for sure, we are very sensible on germs and biological active ingredients. For sure, that has to be realized. I would say 150% safe, that no germ and bacteria are leaving this plant. So it's done with a simple biological treatment to reduce the biological ingredients or the organic ingredients. And we have to, a second step is to reduce phosphorus and other nutrients which are in the waste, in the cow water. And for sure, to reduce the germs, there is a really sophisticated disinfection step necessary in order to keep all hygienic requirements as good as possible. I mean better than possible. Yeah, okay. And in the end, there will be a filtration step which takes out also the salts and the minerals and reduce the conductivity and this. When you then look on this more schematic thing, a water flow of 100% coming out of a spraying tower, for example, can be reused. More than 80% of that can be reused as a drinking water or as a boiler feed water or for a cooling water. That means these 80% you do not need to buy. You do not need to purchase. You do not need to, and that is a saving. You take the milk, take the water out of it and make it to drinking water for your process. It's incredible cool. Yeah, cool. Yeah. But in fact, from 100% of cow water, you can reuse more than 80%. Isn't it a word? And now some facts for the fact lovers. The TOC, for example. Okay. TOC, for example, in the inland is taken out at the first step to more than 70%, and then the filtrate of ultrafiltration. So in the end, we have less than 1% remaining in the drinking water. Benefits, highly efficient and operationally safe. And we have future projects which will be realized because they have already realized this is a chance for saving money, for saving environmental impact, and that's the point. And okay, I think you do not think about beer or something, you are dairy people, or can it be in the evening, or I don't know. But at a brewery, we already realized wastewater, real wastewater from production, making to process water, used in the process again for boiler and for the cooling towers. Brewdog, and this brewery is a growing brewery. And I'm sure if you do that, you are a growing and a future-oriented dairy. I would say thank you very much. Future for the cow.
Hello. Give me this one. Okay, thank you very much. And we have another speaker, Miss Katrina Lingerden. And she will be speaking in the area of strategies in improved energy efficiencies in dairy processing. She is having a master's degree in engineering, a dynamic technical professional with over 20 years experience in dairy processing equipment and various roles. She currently holds the position of Senior Dairy Technologist in Tetra Pak Dairy Center of Expertise, and she has solid over 10 years reputation in supporting customers in specialized projects, research and development, and technology scouting and conducting workshops. Her involvement in R&D works has included the project's aim, developing processing equipments of reduced energy and water consumptions, improve product quality, as well as exploring new applications. So with this, I request Ms. Katrina to deliberate her deliberations here, and so time limit is within 15 minutes, please.
Yes. Okay, thank you very much, Mr. Chairman, and thank you very much to IDF for this very nice event. I'm very happy to be here to present to you today. Let's see if the technology of this one is with me. Okay, so there are, of course, many reasons why a milk producer would be interested in looking into energy efficiency of their process. Okay. The two main reasons, however, are cost, because energy always comes with a monetary cost, while that cost may vary from region to region. The second reason is normally environmental sustainability, as some sources of energy have been shown to have a detrimental effect on the environment. How do we work this one? Fantastic. So if we want to reduce the cost and the environmental impact, it is of course important to look over the whole value chain. This goes for energy as well as for water, raw materials, greenhouse gases, waste and effluents. It is at the dairy where we have the greatest amount of energy where the greatest amount of energy is consumed. But today I will, however, focus on the processing part of the dairy operations. And we might ask ourselves, how far do we have to reach in our ambition to reduce the environmental impact? Well, the answer is to a zero net level. That's not very difficult to answer. The difficult question is, how do we get there? And before we proceed with this presentation, I would like to do a short exercise with you here in the audience. So, 10 years ago, how many of you owned an electrical vehicle? Would anyone who did that, please raise a hand? No one? No? Is there anyone who today owns an electrical vehicle or is looking into buying an electrical vehicle? Yeah, quite a few of us, right? And so that is how quickly the electrical vehicle technology has happened. It's a big change in a very short time. And just imagine if we could have the same change within the dairy processing as well. Just food for thought. There are 4 main strategies to reduce energy efficiency, increase energy efficiency. Avoid, optimize, recover, and switch. Now, avoid, optimize, and recover, quite easy to understand what they're all about. Avoid is, of course, the best way of saving energy or water or anything is to not spend it to begin with. Optimize, to optimize the efficiency and availability, will have a positive impact on sustainable performance. Recover, where we cannot avoid to use energy, we should try to recover it to the largest possible extent. Those are kind of the conventional ways of looking at energy efficiency. Switch is a bit new, and it's all about looking into changing from fossil fuel-based energy into green energy. For instance, green electricity, in order to reduce the greenhouse gas emissions. So let's start with avoid. Now, avoid is all about how we can design production lines and process operations in order to reduce the number of steps, but still produce the same product. The example I have here is the one-step technology for ESL and UHT milk production. In this line, we combine separation, standardization, and UHT heat treatment into one step. We do not have any pasteurization step, and therefore we do not have any intermediate pasteurized milk tanks either. These would normally be included in a traditional line. By removing the pasteurization step, it's quite easy to understand that we save a lot of energy. But removing the intermediate storage tanks also saves a lot of energy, specifically when it comes to CIP. CIP is very energy intensive. Removing any equipment where we can remove and decrease the CIP requirements saves a lot of energy. Typically, with this kind of solution, we can save somewhere between 25 and 50% of energy, going from the traditional to the one-step line. And as you can see on the slide, there are other benefits as well when it comes to water usage and greenhouse gas emissions. The next step is to optimize. And optimize we can do in many different ways. We can exchange a piece of equipment into a more energy efficient equipment. We can change the line setup so that we can use less energy consuming equipment, or we can go from manual to automation, manual operation to automated solutions. And I'll give examples of all of these three alternatives. So let's start with the most energy efficient separator ever. So in the Tetra Pak milk separator, we've long worked with the hermetic design and the airtight technology. This in itself reduces energy a lot. But if we combine this with a new ANCAP technology, we can make even further reductions. The ANCAP technology is all about creating a vacuum in between the rotating bowl of the separator and the outer shell, and thereby reducing the friction losses and the energy consumption. In total, we talk about 40% reduction of energy consumption. The next example is homogenization. Now, homogenization is a very energy-consuming process operation, and by going from full stream to partial homogenization, where we only homogenize a part of the product that contains the fat, we can reach really high numbers of energy reduction, up to 80%. And finally, my final example is about doing inline standardization. I think most of you have heard about the benefits of going from manual batch standardization into inline standardization when it comes to product losses, because of the improved accuracy of cream dosing. However, when going from manual to inline, we're also removing tanks. And if you remember what I talked about tanks earlier, tanks require a lot of energy when it comes to specifically CIP, but also agitation. We calculate that for one 20,000 liter tanks that we can remove from the dairy, there's an energy gain of over 2,500 kilowatt hours, just based on the agitation. And then in addition, of course, we also have the benefits from the reduced CIP. The next step is recover, or the next strategy. And I think the previous speaker talked a lot about recovery of different types. It can be recovery of water, and it can be recovery of CIP chemicals, but in this case, it's about recovery of water. In this case, the scenario we have on the slide is where we use an RO filtration solution on white water. And white water is water mixed with either pasteurized milk or raw milk. By separating the two, we can recover 2/3 as water and 1/3 as milk solids. It's a huge recovery. And of course, since most of the environmental load from dairy comes at the farm, it's very important that we eliminate as much waste as possible. Finally, we come to the switch from fossil fuel to green electricity. And we can, of course, do this by just exchanging our gas or oil, steam supply into an electrical supply. But we can also go one step further. In this concept, we're using a heat pump in our direct UHT systems. Now, the direct UHT systems, there we have a steam injected into the milk to bring it from 80 to 140 degrees. Because we have diluted the milk with adding water, we have to remove the water again from the milk, and we do this in a flash vessel with the help of vacuum. The vapors are condensed in a condenser, and this is where the heat pump can be used. By attaching the heat pump to the condenser cooling water circuit, we can recover heat from the cooling water and create new steam and new cooling water. In its essence, we can create a whole new closed-loop system with the addition of electricity. And the good news is that the amount of electricity we have to add is only about 50% of what we would have to add if we were creating new steam. So very big gain in energy reduction. But of course, if we have an electrical supply of green electricity, we can have very big greenhouse gas emissions as well, up to 100%. Finally, just a few words on advice on experience from the dairy industry. So not a lot of dairies know where they have the consumptions and their losses. Generally, they have a good idea on an overall plant level, but they don't know specifically where the consumptions or losses are generated or in what part of the dairy, really. So our recommendation would be to really measure and log data to get full understanding of where the energy is consumed and where you can make an effort, and then make a plan of how to do it and make sure to pick the low-hanging fruits. Thank you very much.
Thank you very much, and you have limited your time within 15 minutes. Thank you so much once again. So now we have a third speaker, and Dr. Hari Metharail, and he will be speaking on driving consumers' innovations through novel processing technologies. Dr. Hari is Vice President, Product Research, National Dairy Council, Dairy Management, Rosemont, Illinois, US. As a Vice President of Product Research and Dairy Management, Inc., Hari leads various product research programs in cheese, fermented products, and dairy beverages. Hari also coordinates activities across the different dairy centers and innovations lab, and part of the National Coordinated Research and Technical Center of drive dairy innovations and sales on behalf of America dairy farmers. Hari has over 19 years of academic and industry experience and has served as a Pepsi company in the United States, Nestle India, and National Dairy Development Board in India. Now I invite Dr. Hari Mesrail to deliver his talk.
Thank you, Mr. Chair, and thanks first of all to IDF for inviting me. It's a pleasure and an honor. More importantly, I'm kind of dating myself, but I could meet some of my colleagues, friends, professors, mentors after more than 20 years, so that's a wonderful opportunity for me. So with this, I'll start my presentation, and more importantly, I think this is not the presentation that I wanted to upload, so there's a different presentation. I think I provided it in the morning. There was a different presentation that I provided in the morning. Yeah, that's fine. I think I'll go ahead. So there's a very important component in communications which is called BLUF, that is bottom line up front. Okay, so any innovation that is happening has to be consumer oriented. So that was a slide that I wanted to show up front here. But obviously that slide will come in the later slides. I am from DMI, Dairy Management Inc. This is a body that is being funded by US dairy farmers, some 30,000 plus US dairy farmers that put money into the checkoff program to help increase sales and trust in dairy. As you can see to the bottom of the slide, there are a number of companies that DMI manages. I am from the National Dairy Council, which is primarily the research wing of DMI. We have different other organizations like USDEC, which helps with exports of dairy products. There are certain visions and priorities that our CEO, Bob O'Brien, has just laid out. We call it the ASPIRE, which is an acronym for Action for Sustainability, People, Innovation, Reputation, and Exports. It's pretty self-explanatory. I come under the innovation pillar, and I also help a little with exports. So how do we, as a product science group, help support these business priorities, okay? Which is basically to increase sales and trust in dairy. So we do it through research, okay? So we drive innovation through supporting a lot of pre-competitive research across different dairy universities in the US. I'll show a few examples. We help with talent development, both undergrad, graduate level, and continuous talent improvement. And we also offer innovation capabilities. So these are innovation labs at different universities that companies can just go in with and help drive their innovation efforts. So how do we achieve all this? We have 6 dairy centers in the US, okay? So I'll start from the eastern side. So our first research center is at Cornell University. Okay, we call it the Northeast Dairy Foods Research Center. It's led by Dr. Dave Barbano. He's a veteran in this field. This center specializes in milk quality, beverages, etc. We have another dairy center led by Dr. Marianne Rick. She's at NC State. We call it the Southeast Dairy Foods Research Center. This is an excellent center for sensory services. Okay, any product that is launched in the US probably has touched this center. So we fund this center. The biggest of our centers is in Wisconsin. It's the CDR, Center for Dairy Research. Okay, it's Dr. John Lucy leads it. Wisconsin is a state for cheese, so they have a state-of-the-art research capability there. Probably next year, the IDF is happening in Chicago, so probably they'll take you for a tour to that facility. The Midwest is very good for ingredients, a lot of filtration happening there. The Western Dairy Center is Utah State, Dr. Eric Bastian, and the California one is Veronique. So these centers help drive innovations in the US. So the innovation capabilities, we just came up with a booklet. If you can scan this QR code, you can download this booklet. It has vast amount of resources for all the resources that we have at the different centers, etc. With this, I'll start my presentation, and any technical presentation as I start, I like to show this graph, okay? This is the dairy product consumption in the United States, milk equivalent basis. This is rising. If you look at the equation of the line, it's roughly around 2 pounds of dairy per capita per year. So it's pretty much increasing. The only thing that is happening right now in the US is consumers are now shifting from one product category to the other. Fluid milk is in a decline, correct, but what is happening is consumers are now consuming more of cheese, yogurts, etc. And that is why you see the increase in per capita consumption. Roughly around 16 to 20% of the milk solids produced in the US is exported, so increase in exports is also helping drive the sales. With this, I'll come to some two core technologies that I'll be talking about. Again, this is a lot of research that you have been funding. I'll talk a little bit about insights on these products, and primarily it's going to be snacking and health and wellness innovation. So first is the snacking. So this is what the snacking scenario is right now in the US, okay? The retail cheese sale category is roughly a $22 billion category. In that, snacking is roughly a 3.5 billion category. But most of the snacking is happening in the refrigerator aisle. So what are we trying to do with this is, we are trying to encourage or push some research that can push the snacking category of cheese more into the non-refrigerated aisle, okay? So that we can source some volumes from other snacks like chips, potato chips, or corn chips. This is the eating occasion of snacks in the US. I haven't shown previous year figures, but what is happening is snacking is increasing tremendously in the US. And this has something to do with post-COVID work from home scenarios where consumers are consuming a lot of snacks. So there's a lot of opportunity for dairy snacks, especially cheese snacks, to come and help in this category. This is what is happening in the cheese snacking category, especially from string cheese, etc. So cheese is mainly an afternoon and an evening snack, okay? So there's always an opportunity to push it towards a treat or sharing a snack with children. But what happens there is in those times, it's mainly the chips or the corn chips that are consumed. So there exists a tremendous opportunity for cheese snacking to happen here. So what are we doing in this? I'm going to share a couple of projects that we are funding currently. So this is a project on microwave vacuum drying of cheese that we are funding with Cornell University. The PI is Dr. Carmen Moraru. So this technology is already a commercial scale technology that is available, but it's primarily used for vegetable drying, etc. So we are funding a project on this to understand how different cheese types, when exposed to microwave drying, behave. And we are trying to replicate the sensory and the rheological characteristics of corn or potato chips. So this is what we are doing right now. We are looking at different natural cheese varieties. We are looking at different effect of different pressures, effect of different vacuum levels, effect of different size of cheese, and how the sensory and the textural attributes can be changed. So this is one of the big projects that is happening on the snacking side. How can I not talk about processed cheese when I'm in India? So this is another project that's happening at South Dakota State. The PI is Dr. Lloyd Metzger. So what we are trying to do here is come up with a clean label processed cheese type of a product, okay? Consumers in the US are demanding a little bit of cleaner label, especially without the emulsifiers, etc. So we have come up with this new process technology where we're trying to use filtered milk ingredients and functionalizing them so that they can emulsify the fat during processed cheese manufacturing to come up with a product that is clean label. And there are some early takers for this technology. With this, I'll go to the second area of my presentation, which is innovations in health and wellness. Okay, consumers are increasingly demanding beverage products to do more, especially functional foods. Post-COVID, $18 billion is the increase in sales of functional food products globally. Okay, and even in the US, it's roughly around 7% growth. So there is a tremendous opportunity for functional foods, and it's a growing category. Wellness can mean different things to different people. Okay, it can be immunity, digestive health, and calming. We are actually funding projects in all the three categories. So we have something on immunity, which I'll talk about in the next few slides. We have something on digestive health. We just had a publication in the Journal of Agricultural Chemistry where we were trying to do something with probiotic bacteria. And then we are doing a project on calming too, where we are trying to isolate bioactive peptides that could help with some of the calming benefits. This is a project that we are doing again at Cornell with Dr. Ali. What we are trying to do here is we are trying to increase the heat stability of lactoferrin when subjected to intense heat treatments, okay? So primarily, lactoferrin when isolated, it's a minor protein in milk, but it's being isolated from milk in commercial quantities. The US, some players in Europe are isolating it now from milk. Primarily used in the infant food category, but it has heat stability issues, as we all know, and it's a functionality-driven protein. So what we are trying to do in this project is we are trying to form a coacervate of lactoferrin and some food-grade biopolymers so that the heat stability of lactoferrin when subjected to UST treatments or ESL treatments are increased. And we have got some very good encouraging results. We have just patented this process, and we'll be scaling up this soon. With this, I would just like to end my presentation with a slide, which is ultimately about consumers. Okay, there's a very, very famous Howard quote saying that we need to know what our consumers want even before they do, because that is what is driving innovation. Okay, so we need to develop platform technologies to innovate with dairy protein and ingredients, and there's a concept of jobs to be done. So you need to design products that the consumers want, and this is a cycle. Okay, consumers' needs keep evolving, and we need to kind of master this cycle and predict where the consumer needs are going in the next few years. With this, I will end my talk. Thank you. Thanks.
Okay, thank you very much, and also within time limit, thanks once again to you. So we have another speaker, the fourth speaker, Dr. Ashish Kumar Datta. He will be delivering his talk on market milk innovations and processing and packaging. Dr. Ashish Kumar Datta is a professor in Agricultural and Food Engineering Department, Indian Institute of Technology, Kharagpur, West Bengal, India. Also, he is the emeritus, the scientist emeritus professor there. Also served the IIT Kharagpur in several capacities. And with this brief CV, because he is a very good teacher, and so I now invite him to deliver his talk.
Thank you, Mr. Chairman, sir. And I'm happy and proud, honored to be here to present our laboratory work in front of this August gathering. We start here with the market milk scenario in India. 45% of market milk is sold as milk, and 55% is converted to dairy products. Total milk production is 210 million tons per annum. This is 2021 figure. Per capita milk consumption is 400 gram per day, including dairy products. So you multiply it by 365, you will get the kg per year, per capita consumption. 1,90,000 village cooperatives, 1920, and 12 million dairy farmers are members of these cooperatives. Initial bacterial population in fresh milk is 0.8 to 1 million per milliliter in the DOC. Bacterial population doubles every 15 minutes at room temperature. Refrigeration and chilling is a must prior to and post pasteurization. Sterilization over pasteurization in the subcontinent. My talk is going to center around the sterilization concept, because we felt that sterilization as it is available now is a very good substitute for refrigerated storage and transport. Sterilization can preserve surplus milk without having to force convert to other dairy products. Surplus milk, once sterilized, can be disposed of during the lean season. Thermal demand of milk originating in India. For our global audience, I would like to emphasize some points. The Indian milk quality is poor. It is not as good as in the developed economies. So some figures here, 150 mesophilic and 50 thermophilic spores per milliliter of milk in India. Most heat resistant mesophilic spore is Bacillus subtilis. Most heat resistant thermophilic spore is Bacillus stereothermophilus. D145 for Bacillus stereothermophilus is half second, 0.533 second. Total sterilization effect is 9 log cycle. So 10,000 liters or in 20,000 half liter packages can be rendered spore free. And the combination is 2 second holding and 2.8 second cooling. Recommendations for rural cooperatives. Indirect type milk sterilizers are better suited for rural cooperatives because they require much less initial investment. Capacity 1000 to 2000 liter per hour, heating up to 145 degrees Celsius and holding for 2 seconds, cooling for 2.8 seconds. Converted form-fill seal machines may be adapted for semi-automatic aseptic packaging. Aseptic packaging trials at IIT laboratory, design, development and fabrication of machine capable of aseptic packaging, development of air sterilization system for drying wet packaging material and sterilizing contact surface, optimization of suitable combinations of time, temperature and concentration for hydrogen peroxide dipping of packaged material, testing of developed packaging system for zero contamination. This is the kind of the device that we made, and we are filling the sterilized milk into pouches through this machine. Results of time, temperature, 10% concentration of hydrogen peroxide solution. We settled for 90 second contact time and temperature combination of 50, 60, 70 and 80 degree. And we also had the number of log cycle reduction. You can see that the right hand side there was no data available. So 90 second is the appropriate contact time to reduce the colony forming unit. Setup number 7 yielded the most stable heat sealing of HDP, that is setup 1, 2, 3, 4, 5, 6, 7. 7 means voltage was 26.7 volt, current was 0.388 ampere and the power was 10.28 watt. See, the challenge here is you cannot over seal it when the plastic will melt, and you cannot under seal it which will not join. So that combination here you can see that the 2, 3, 4, 5, 6 and 7, 8 seconds were the sealing duration, and our setup number 7 had effective sealing after 3 seconds. So that is the one we preferred. 4, 5, 6, 7 also had effective sealing, but that we somehow discarded because they are taking a little longer duration, so power consumption is more, package filling time is less, so we went for the shortest sealing duration. Then shelf life stability of sterilized milk, yellowness index. This, the curve is a little bit misleading. You can see that the value goes from 19.8 to 21.2. It is not really much change in the yellowness index, and that is after 2 weeks of storage. Whiteness index, this is 16.5 to 15.2. This is also not much shift, but the curve, just showing the 15 days, it is appearing to be very significant. Viscosity of sterilized milk 2.5 to 3.4, 15 days. So the milk was found to be keeping well for 15 days. So here, before I present the conclusions, my appeal to the gathered audience here is that, here is a gray area between aseptic packaging that we know now and the form-fill seal machine packaging that we do for the market milk. Something in between probably can be developed, and that will be able to provide unrefrigerated sterilized milk from the rural cooperatives. So our conclusions are: packaging material we used HDP, concentration of hydrogen peroxide was 10% volume per volume, temperature of H2O2 was 50 degrees Celsius, dipping time was 90 seconds, heating air temperature was 140 degrees Celsius, heating air velocity was 20 meters per second, ceiling current was 400 milliampere, ceiling voltage was 12 volt, resistance of nichrome at 30 ohm, and shelf life of packet was 15 days. Cost of machine 2.5 lakhs as of today. So there are some references, the students who worked on this thing. That's all I have.
Okay, thank you very much. Thank you. So we have a last speaker, Professor Tridit Kumar Goswami. He is a professor of Department of Agriculture and Food Engineering, again from IIT Kharagpur. He will be delivering talk on innovative approaches to improve dairy products quality during processing, storage, and transportation. Professor Goswami has a specializations in the area of food processing and preservation. He served IIT Kharagpur in different capacities, right from the technical officer to professor. With this brief CV, I now invite him to deliver his talk.
Thank you, Mr. Chairman. I am thankful to the organizers for giving me this opportunity to interact with the August gathering. When we were students, in this kind of gathering, we used to tell the last speaker has the benefit of either extending his speech or reduce it to minimum so that the word which you used to say that speech is good, but food is better. So next session will be food. So obviously I will not linger it much. Again, from the topic which was given to me to share with you is basically on the basis of quality. And it's my privilege to tell the world that National Dairy Development Board, our Anand, Amul, and many other such organizations have taken care of the quality of milk and milk products to the level which can compete any part of the world. So this is really a white revolution which came out long back by Dr. Kurian and many others. However, coming to my point, that obviously quality starts from the milk which we receive. If the milk is not good, it cannot be made better. This is by definitely we all know. Now, what we understand by the innovation, that to improve the quality of milk and milk products, I should say, like powder, whey, milk protein, concentrate, etc., and many confectionaries. So after receiving the milk, lot of processing are done, primarily chilling, then it is to be stored, then if required, depending on the products, centrifugal separation, pasteurization. My colleague said about sterilization. I will come to that. Homogenization, then ultrafiltration, spray drying, etc., many, we call it unit operations, are involved. Generally, pasteurization is done between 63 degrees centigrade and 72 degrees centigrade. But it is not the temperature only. Any heat treatment is a function of both temperature and time. So 73 degrees centigrade is 15 seconds, whereas 63 degrees centigrade is for half an hour. Now this leads to another thing which is associated, of course, with the cold chain, because milk and milk products, whatever it be, is always supposed to be under a cold chain. Otherwise, a term which we call the temperature quotient, which is of course a ratio of rates of reaction at a temperature of T plus 10 degree to that at temperature T. That reaction can be any, like any reaction which we can think of. So everywhere it is applicable. So if we go back to the previous slide, that we said 63 degrees centigrade half an hour and 72 degrees centigrade 15 seconds. So the total time temperature energy which we are putting into the pasteurization process, this factor, that temperature quotient, which every 10 degree rise will make it almost double, more or less, or every 10 degrees centigrade lowering will make it half. So any changes, any reactions associated with the increment of the time and temperature, a combination, will be obviously better off when the product is less. So 72 degrees centigrade and 15 seconds is obviously much better than 63 degrees centigrade and half an hour. However, we know that all dairy products are perishable, whatever it be, they are perishable. And what we mean by the term perishable means the moment it is milked, from that moment it starts deteriorating. Obviously, it is also a function of time, and that is the reason why this statement is made that take dairy foods straight home from the store or from the catch or from the milking station and immediately put them in the refrigerated condition, because this is a part of the cold chain. So the more, as my previous speaker, Professor Datta, my colleague, said that we should go for sterilized product, but there are many people who are definitely, yes, sterilized product is always good in the sense that we don't have to make the cold chain. It can be stored at a room temperature. But the change in quality is much, much more than what it would have been for pasteurized products. This part, many of us, like my previous speaker, Professor Datta, has covered up, that it should have, for quality, coming to the quality only, the automation is a must. Date back to 4-5 decades, where everywhere in the world it was a hue and cry that no automation, because that will remove the possibility of the people's engagement, or whatever we call that their jobs. But today, with respect to quality, it is a must. Right from the milking or even rearing of the animals, every stage, if the automation is implemented, then the finished product, which I said in the first slide, will be of very good quality. Now, packaging, again my colleague has already spoken about some part of the packaging. So since time is involved, and there are some people also, some of my previous speakers also covered about some novel technologies, out of which we are also doing in our institute, high pressure processing. HPP we have, and we are also doing that. Yeah, it is very costly. There is no ambiguity in that. The machine itself is very costly, so the product is also highly costly. So it cannot compete with the normal, this milk which is subjected into the market. Then other processes are also under research condition. I don't say that it is in the commercial stage, like this PEF or ohmic treatment. All these are in the laboratory scale, yet to find the commercial application. Now, many food products, typically from milk or dairy products, they are being fortified, I should say the word, fortified with nutraceuticals. Many such products, and also some flavored milk, they are gaining the market and the people's choice. Now, what is the ideal storage temperature? Obviously, in Fahrenheit it is 34 to 38. In centigrade it is a decimal. That's why 34 to 38 is easy to remember. Now, for storage, there are two types of storage. One is above zero and another is below zero. Mr. Chairman said that I was a part of the quality ice cream, and where I was one of the officers. And there, obviously, a lot of things have been done. I am not coming to that. But two types of storages, one above zero and one below zero. Above zero is most of the milk and milk products. Most of the milk and milk products are stored at above zero, ranging from maybe plus minus 4 degree to maybe around 15 degree depending on the product. But if it is cream or ice cream, then it should have a temperature of minus 18 or below. Now a typical word minus 18, why? I hope all of us we know. Why minus 18? Because my students who are here, for them, that in early days, several, not decades, maybe centuries back, when Fahrenheit was there, no other scale, that time people saw that if the temperature is 0 Fahrenheit, then it lasts. And I am talking about several centuries, so that time this type of transportation and many other things were not there. So they took a lot of time to travel from one place to other, but they carried it at 0 Fahrenheit. And 0 Fahrenheit, if we convert, it comes to 17 point some decimal, which is rounded off to minus 18. That is why 18 has come. You'll see in all the books that frozen food storage temperature is minus 18 or below. Coming to the transportation, obviously, depending on what product you are transporting. Definitely, if you have milk to be transported, then the temperature maintained is around plus minus 4 degree. But again, if it is ice cream or cream products, then the temperature has to be minus 18 or below. During our college time, we went somewhere and our librarian was a lady and she asked us, what did you bring for me? We said, Madam, we brought ice cream from Darjeeling, but unfortunately during coming to this place, it got melted. And we have the cup only. And this is the reality, that when you are taking ice cream, if you are not taking care of the temperature, then the product will be irreversibly transferred to the liquid. and once it is, you cannot redo it. Like milk, if the temperature goes up or down, you can play with it, you can redo it. But ice cream, you cannot do it because it's a mixture of air and the ice cream mix. So if air goes out because of melting, it will not be able to be put back to its original. So we need some transportation systems which have the capability of maintaining the temperature -18 or below. Generally, any type of mechanical refrigerated system are normally used, even for milk also. Mechanically refrigerated vehicles are used to make it 4 degree because that you can definitely control. So if it is 4, no problem, you can do it with mechanical refrigeration, normally vapor compression refrigeration system. And if it is -18, then also the same vapor compression refrigeration system with obviously changing the compressor, condenser, all other parts, and you can maintain it to -18 and transport from one place to other place. It reminds me when I was in quality, almost 35, 40 years back. So that time, there was a problem in a cold store where there was sudden breakdown of the power. And I was working with cryogenics. So I was told by my executive director that, can you do anything with this, the whole bunch of ice cream of a cold room? That's a huge quantity. Then I had taken liquid nitrogen, risking my life, because nitrogen is suffocating, and really we could have saved it. But that is one time, right? But for transportation, with the use of liquid nitrogen, some polar stream refrigeration developed by British Oxygen was, or rather is in the market. Unfortunately, I know it, that BOC wanted to establish it in India, but could not do it. I don't think any part of India this polar stream is working as of now, because of some misconcept and wrong feedback. However, for ice cream and others, and there are also, I hope you have also experienced that if you want to take ice cream to your house from a distant place where ice cream parlor is there, then they use dry ice. It's not for a bulk one, for small ones, they use dry ice because dry ice will sublime and giving the latency of sublimation. And the ice cream will remain cold and hard. Because if it is again becoming soft, then you cannot redo it. Like soft tea you take from different parlors, if it becomes that, then it will not reach your house. So dry ice will help that. Apart from that, another thing, I hope if you have ever seen that ice cream lollies which are made, they are made in a pond kind of, I should say that a pond kind of reservoir where eutectic mixture of salts are made with solution, and the temperature can be brought down to even -30, 40, that level, with the help of obviously a primary refrigerant like either ammonia or freon or any such. So this helps for transportation, for production of the dairy products or sending milk from one place to other. I know that from Anand, at least 200 to 400 kilometers or even 1,000 kilometers they do transport. And they do have the mechanical system of refrigeration for transportation. Along with it, yes, there are many other things which are coming up, like nowadays PCM, that is phase change material. This is a new topic for research students are doing, that phase change material, if it is given, obviously not for milk, but for in milk products, phase change material can take care of the heat inlet and can keep the product safe. Other things could be along with the solar energy. Again, these are under research condition, not in the scale of commercial use. I am very grateful to all of you to listen to me. Thank you very much.
Okay, thank you very much. Now, we have 15 minutes with us and we can take a few questions. Yeah, please, that's all. Dr. Patil.
Chairman sir, can I sit?
Thank you. Good morning. My name is Arun Patil. I am Vice President of Indian Dairy Association. And prior to that, I am a dairy consultant. Basically, I am a dairy engineer. I have been designing the projects from 5,000 liter per day handling to 1 million liter per day handling. I am very impressed with the presentations today. And this is very important that we have to address the energy conservation, water conservation. To start with, I will just address one thing of Mr. Thomas about water consumption. I worked with National Dairy Development Board for more than a decade. And those days we were designing the plants with 2 meter cube water requirement per meter cube of milk once upon a time. Now I'm happy to inform you that it has come down to almost 1 to 1.25 meter cube per meter cube of milk handle. This is for major plants. But when we are designing the smaller plants, meaning thereby less than 100,000 liter per day capacity, we have brought it down to 0.5 meter cube to per meter cube of milk handled, especially for liquid milk plants. In case of products, definitely it is slightly higher. And some of the states in India have got a now zero discharge policy, meaning thereby whatever water you use, you have to utilize after treatment there itself. One difficulty we faced for designing 1 million liter plant, where we wanted to convert total effluent into a potable water, and of course white water, as you say. The cost was coming almost 3 times the bottled water which is available today in the country. In Indian perspective, a bottled water costs around 10 rupees a liter, whereas this cost was coming close to 27 to 28 rupees a liter. So that was the difficulty. But definitely that doesn't deter us from going for that, and we are doing. So that was one thing I want to share. Coming back to Ms. Katrina, you have been developing the equipment, definitely highly energy efficient, but there is a little hitch. In countries like India, we don't have all the places bigger plants where they can put up 20 KL and 30 KL and maybe 10 KL equipment. So we need smaller equipment which will be equally energy efficient. And this difficulty we face, because out of 2,000 plus dairy plants in the country, only few hundred are major plants, which are handling million liter or 500,000 liter. So this is one small suggestion for that, which will help the industry. And we have to go a long way because we are handling hardly 30 to 40% of the total milk into the organized sector. So that is one thing which will help. So with this, thank you very much. These were little contributions I thought I will just share with you.
And dear sir, what was the question?
I wanted to share our experiences with you.
Okay.
Yeah.
So I can do also a little statement.
Yeah.
Everybody is buying water and everybody is buying milk. And then I think when you know this, to compare the price of milk and the price of water, then you know the real value of water. Because normally the water supplied by state or somewhere is too cheap, because it is water is so important to use and to care of. And therefore I would say look on this comparison, and then I think the consideration of costs for reutilization is different. But if you compare something like supported water price, we all are thinking economically, but the main point is the value of water normally is under the real value of water, and that we have to care for. The water is more essential than we think of.
Okay, thank you. Yeah.
Sir, may I add up a little? Sir, may I add up a little to him?
We can take this question first and then
No,
later.
with regard to water.
Okay, just please.
It is,
Go ahead.
it is evident that water has always to be microbiologically safe for drinking. There is no ambiguity in that. But as he said, that the quality of water, from the engineering point of view, any water which is used for heating any or cooling anywhere, if the water quality is not good, it will form scale. The moment the scale formation is there, it will minimize the heat transfer and increase the energy requirement, etc. So water has to be one of the best quality for commercial use or for our consumption.
Okay, thank you.
sir.
Thank you, please.
Thank you. Thanks, Chairman Saab, to allowing me to speak. Myself, Dr. Raja. Presently, I'm working with the UNDP project for small and landless farmers. And we are totally dependent upon the efficiency of this dairy industry. Particularly earlier, I think as Mr. Arun Patil told me, we should have an energy audit. Such an excellent presentation you have given, but it's not going to the ground level as such. Number one. Number two, even this in the case of cooperative dairies also doing the same thing, and some of the private dairies also doing the same thing. Ultimately, what happens is affecting the efficiency and also affecting the cost of consumers' packet. So we should try to take a policy here so that the energy audit should be a statutory requirement for the dairies, either it may be cooperative, it may be private, instead of giving subsidy to some of the dairy farmers also. This is what my humble request, Chairman, because you have a vast experience, so we expect your recommendation can be honored by the concerned authorities. Thank you, sir.
Okay, thank you so much. And next, yeah, please. Wait.
Thank you very much. Myself, Birendra Jha from HR Lab. One pinpoint question, what I want to address here is that throughout the summit, we are listening only about milk, and nobody is talking about the waste. I think this is cow dung. What is the better utilization of cow dung? And it was my expectation that when this presentation is going on here, then
I think,
something.
may I interrupt you here? Probably we have another session for this, and this is because
Okay,
it's a specialized
okay.
session.
I will conclude this.
We must be talking about the other things, so byproducts of the animals, surely. But here, if you have a very concrete or like this, any
Yes.
Go ahead, please.
My pinpoint questions is towards the two emeritus professors from IIT, Kharagpur, is that what innovative approaches basically the IIT or at the IIT level is going on to convert cow dung into ethanol? Because we have been engaged particularly during the last 5 years in converting cow dung into ethanol. And now ethanol is the need of the hour. So what the IIT is doing there, can you address it please? I shall be more.
Chemical engineering department is doing some work on that. Chemical engineering department of IIT is doing work on that line.
So far I know, biogas was produced commercially in our institute, and it has been also commercialized more or less. But use of this biogas to ethanol, as of now, I cannot exactly say that anybody has developed such kind of thing, as of now. Maybe somebody
Okay,
will
okay,
take
thank
up.
you very much. We will take one question from him. Yeah, please. And then we'll come to you.
Yeah, good afternoon, everyone. I am Bipin Patel from Banas Dairy, part of Amul. My question is to Dr. Robert, who has been very well explaining about the wastewater treatment. See, we have been using our effluent treatment plant and giving a tertiary treatment to reuse that water. But the biggest challenge or the prominent challenge what we face is the RO reject water, because it has very high TDS to the tune of around 10,000 ppm. So the technology that we need to have has to be optimized and economical technology from the capex and opex point of view. Right now, technology is of evaporating that RO reject water and drying it to convert into minerals, but that is very energy intensive. So the question is, do we have an economical solution to treat the RO reject water, which has very high TDS, so that the people get prompted towards the tertiary treatment of effluent treatment water and reuse that water as a boiler feed water or floor cleaning, or the condenser backup water in the refrigeration plant, which is also to the tune of 20 to 25% of the water consumption in the dairy industry.
Yeah, you asked to treat the reject water of RO.
Yeah.
And which RO you mean? In a process somewhere?
No, it is, we have an effluent treatment plant and we treat that water and bring down the BOD and COD to the Pollution Control Board requirements. But the TDS in that water is very high, around 1500 to 2000 ppm. But then we convert that treated water through RO and utilizing back in the dairy. But the concern is the RO reject water, which has TDS to the tune of 8,000 to 10,000 ppm, which we cannot dispose it directly on the field or in the effluent treatment. So what technology you have, economical technology, to treat that RO reject water?
Yeah, okay. Yeah, basically the effluent is treated first mechanically and then biologically, and then we go into reutilization, or we can, when we do it biologically, we can go for irrigation. But when we want to have a part reused in the factory, there is, let me say, 80% of the produced wastewater, no problem. And this reject water, okay, we can go for another RO, high pressure RO, and then we can reduce this reject part. And this reject part, okay, the last solution will be some evaporation, so you get the solids of the ingredients. Unfortunately, yes, this is energy intensive, or we have to have a big area for drying by sun. Yeah.
Okay, thank you. Yeah, please. This side.
Good afternoon, everyone. I am Sanjeev Sharma. I am part of Milk Fed Punjab. So my question is toward Professor Goswami. This is regarding, I have heard they have developed a prototype machine for septic packaging with shelf life of 15 days. Sir, we are working from 1995 on aseptic packaging in our industry. So the sterilization of the packaging material plays important parts, and mainly we use hydrogen peroxide for sterilizing the packaging material, and the peroxide residue should be controlled to the level which are prescribed by the statutory agencies. So my question is that whether the prototype you have developed that is capable of reducing that peroxide residues in the packaging material or not?
Yes, we have, I did not mention it there, we use hot air stream at 140 degrees Celsius to remove the hydrogen peroxide deposit on the film. And then we, after dipping, we made sure that there was no hydrogen peroxide adhering to the film. So that we have taken care of.
Thank you, sir.
Any other? Okay, yeah, please.
Good afternoon, everybody. I'm Tek Thapa from Nepal. Since we were discussing about market milk, I was wondering if lactoperoxidase system of milk preservation is in use in India. Thank you so much.
Goswami, please. Would you like to respond this?
Not really. It's not used here.
Okay, please. Yeah.
A very good morning to one and all. This is Shreya from ICR NDRI Kanal. I would like to thank all the speakers for the informative session. And as Dr. Hari emphasized that the consumption of cheese has increased, and in India we also have a lot of paneer production. So ultimately we get whey as the byproduct. So my question would be that we usually drain it and it has its own repercussion. So can we have some cost-effective and innovative method that the industry can use so that we can conserve water from the same? Dr. Robert, if you can just help.
Many questions from you.
So you see, water is so in the center of interest. Yeah, we have already realized for utilization of whey or whey permeate. Normally whey, you can separate the proteins off and as a value stuff, and the whey permeate, there is lactose, difficult to separate, but the best thing to produce biogas, and biogas at the moment, you know, it's a value incredible high. So even these waste or waste whey treatment plants can get a return of investment below 3 years. Isn't it good?
Thank you.
Yeah,
Thank
and
you.
just to add, can I? So it's a very good question. So something similar was happening in the US in the last 5 to 10 years, where we had a lot of Greek yogurt acid whey. Okay, so it was a big problem to handle. A lot of work has been done. We are also funding a lot of projects to convert some of the, it's a lactose-rich stream, right? So there was a question on ethanol. So can we use it for production of biogas or ethanol? That's a valid question, right? So probably it can. There are some innovative products also, like how I said, it's very important to understand what the consumer trends are. Actually, I had a slide in my actual presentation where one of our professors founded a company to come up with a hard seltzer. Okay, it's called Norway. It's a raging hit. He launched it in New York. So there are adjacent product categories which can be utilized for products like paneer whey. And like how we mentioned, right? I mean, it can be, whey proteins can be isolated even though whey protein content is a little bit low, right? But lactose can be used as a carbon source for biogas or alcohol production, probably.
Okay, thank you very much. And in this session of innovative approaches to improve dairy processing efficiency and product quality, we had 5 speakers, very eminent speakers, Mr. Thomas Weber. Lot of questions on water. Yes, excellent job you have done. And Ms. Katrina Lindgren and Dr. Hari Mithrarin, Dr. Ashish Kumar Datta and Dr. T.K. Goswami. Excellent presentation by all of you. And this, of course, the presentation we have, we got knowledge all over what with the area of the innovations as well as with the area of process and technology. And also the packaging is very important nowadays. It was excellent, and further the transportations of whatever the quality product we had. So we received a great knowledge from you, no doubt, and all these speakers. Thank you once again I thank you all once again, all the audience sitting here, and giving also the thanks to the organizers for giving me opportunity, giving us opportunity to be here in front of the very eminent people here. And thank you once again. And so then I think the job was over now. Thank you so much once again.
Yeah, thanks a lot, sir, for the wonderful session. And moving ahead, we have the felicitation by mementos and appreciation certificate. So I would like to request all our speakers, speaker one, Mr. Thomas, I request you to please come forward to receive the memento and certificate of appreciation. And to do the honor, I would like to call upon our session chair, Dr. M.S. Chauhan. Can we have a big round of applause, everyone, please? For the next felicitation, I would like to call upon Ms. Katrina. And I request everyone to please give a big hand for all the amazing and really informative sessions. So moving ahead, we have speaker number 3, Dr. Hari. I request you to please come forward and receive your memento and certificate of appreciation. Thank you so much, sir. Now we have Dr. Ashish Kumar Datta. I request you to please come forward, sir. Can we have some claps? Yes. Thanks a lot, sir. And now we have Dr. Tridib Kumar Goswami. I request you to please come forward to receive your memento and certificate of appreciation. Thank you so very much, sir. And with this, once again, thank you to all the speakers for the amazing and really, really informative session. And now, I would like to also felicitate our session chair. For that, we have to do the honor, Shri Santosh Singh, General Manager of Engineering Services National Dairy Development Board. I request you to please come on the stage. Can we have a big hand, everyone, please, for our session chair? Thanks a lot, sir. Yes, thank you so much once again to all our speakers and session chair. And now we have a special announcement. The sessions which is about to happen at 4 to 5:30. Session number 21 on feed, food and waste, which was supposed to happen on Google Hall, but it will be happening here in Rathi Hall. And session number 22 on field practices to detect and mitigate risk was supposed to happen here in Rathi Hall, but now it will be happening in On-Goal Hall. So please note it down. And at last, I have a special announcement for you all. Recording sessions will be available on the mobile apps and webinar platform after the event. The presentations are already uploaded in the resource section of webinar platform, so you can get it from there. For a digital experience of the IDF WDS 2022 Summit, please download the mobile app IDF WDS 2022 from your app store. Thank you so much for now. We'll be joining us back at 2 o'clock for the next session. Till then, enjoy the lunch. Thanks a lot.